horizontal forces. Force downward
This call is now being recorded.
is the weight, and the force upward is the friction. Okay, so this is what we call as free body diagram. We draw the forces acted on the object with its direction, and if there are value, we write the value. Okay, and then B, we are to calculate the resultant force acting on the coconut. So steps given in the textbook. First, to identify the problem, and then identify the information. This is the method for us to follow when we get calculation question. Identify the formula and then solve the problem numerically. So we are to calculate the resultant force. So resultant force is after we combine these two forces, we get resultant force. And then as the object accelerates downward, it shows that the force that is downward is bigger. So bigger force minus smaller force. So resultant force is the weight. The mass of the object is 20 kg. So therefore, the weight we take gravitational acceleration as 10 as 20 Newton. 20 minus the friction, we don't know. Okay. Right, dah habis bateri ke? Alamak. Alah ni, my speaker dah habis bateri. Patutlah berbunyi-bunyi pada tadi. Because just now I have another class. So ni kelas 2, kelas berik-derik. So we are going to use another speaker. Okay. So apa tadi? The resultant force is a combination of force, and it will result the mass of the object to accelerate. So we have the mass and we have the acceleration. So here is ma equals to 20 minus f, and m is 2, a is 9, 20 minus f. Okay, so the calculation is shown in the diagram. Okay, however, if you look at page 11, the gravitational acceleration used is 9.81. Okay, so since the question gave us the gravitational acceleration as 9.81, we need to use that. So saya silap lah. This one I use 10. Okay, if the acceleration is not given, then we take 10 as gravitational acceleration. However, the gravitational acceleration is given. So saya tak tengok dalam buku. Dalam buku is given 9.81. So we need to use 9.81 as the gravitational acceleration. Therefore, the weight of the coconut is 19.62 Newton. Okay, not 20. So this is how we calculate, and after that we can calculate the magnitude of a resistance or friction. Okay, so state the direction of resultant force. Resultant force will follow the direction of movement, and the movement is acceleration downward. Therefore, the resultant force is downward. Okay, so all these are example given in the textbook. I only explaining to you lah how they get the answer. Okay, so this one I think most of you already know because we have discussed this topic last year. Okay, where we learn about Newton's second law, F equals to ma. Okay, so this is the formula, or this is the work done, the cara kerja given in the textbook. Okay, so let's look at example 2. A passenger of mass 60 kg is in a lift. Sketch the free body diagram using the symbol W represent the weight, R representing the normal reaction. Okay, so if the person is standing in the lift, so two forces, one is downward, which is the weight, and R is the normal force because the person is standing on a surface. Remember, normal force is only exerted on the surface onto exerted by a surface onto an object. Okay. B, calculate the magnitude of normal reaction when the lift is stationary. So the passenger is 60 kg and in the textbook given gravitational acceleration as 9.81. So this one, this example I already asked in our previous class, lebih kurang sama. Okay, so if it is stationary, then W equals to R. Okay, if it's moving with acceleration, so this is due to resultant force, F equals to ma, then we can calculate the resultant force. Okay, and since the resultant force is upward, okay, we draw again the body diagram, the free body diagram. This is the weight, this is R, and the object is moving in acceleration at 1.2 meter per second upward. Therefore, the resultant force is upward. Okay, so we can calculate the normal force. And if the person is standing on a weighing machine in the lift, on the lift, standing on a weighing machine in the lift, okay, so the reading of the weighing machine will be shown by R. R akan tunjukkan reading of the weighing machine. Okay. Tapi kat sini dia tak ada tunjuk weighing of it, tak ada tunjuk ada pemberat ke apa ke. So just follow the question lah. So the question asks us to calculate the R. So we know that the object moving upward, so resultant force is also upward. Okay, and then since the resultant force is upward, therefore we can say that R is bigger than W. So R minus W equals to RF. Okay, so this one is already shown in the textbook. Okay, so I think for example 1 and 2, most of you have no problem with it because the situation is not much different from the Newton's second law yang kita belajar last year. Okay, tapi for example 3. Example 3 involve a trolley and a load. Okay, so gravitational acceleration also given as 9.81. Okay, so before we can do any calculation, as in the question, we are to sketch the free body diagram of the trolley. So this is the, kenapa load dia duduk atas sangat? Okay, the load should be down here. Okay, this is a pulley. Okay, so we have a string attached to the trolley to the load. Okay, so let's look at the system one by one. Firstly, we look at the load. How many forces are acting on the load? Okay, can someone respond? Ashley, on the load, this load, how many forces are acting on it? Ashley?
Um,
Yes, Ashley. How many forces?
Is it two forces, teacher?
Yes, two forces. Yes, correct. There are two forces acting on the load, which is one, a downward force, which is the weight of the load, and the other one is from the string, the tension of the string. Okay, so there are two forces acting on the load. Okay, tension and weight. Sebab the load is only held by a string. So weight mesti ada. Every object mesti ada weight because we have mass. Okay, so there is a force downward which is the weight and it's being held by a string. Therefore, the another force is along the string opposite direction to the weight and it is called tension. Okay, and then let's look at the trolley. The trolley, if you look at page 12, this is from page 12 from the textbook. The trolley, and there is a friction acting on the trolley. Okay, so we have a trolley on a table and the table have friction. So my question, how many forces are acting on the trolley? Danushini. Danushini, how many forces are acting on the trolley? Yes, Danushini?
Two.
Okay, two forces. Can you please tell me which direction are the forces? To which direction? Yes, Danushini? You said that there are two forces. Can you please tell me which direction does the forces acting on the object, on the trolley? Danushini? Still waiting for the answer? Okay, we have full attendance. Congratulations. Everybody uh, is here, is present. Horizontal. Okay, Danishuni said that the forces are horizontal. Okay, so one is to the right, the other one is to the left. Okay, so I'm calling upon Abirami Sivaraja. Can you please tell me what are the name of the forces? Can you please identify the two horizontal forces opposite direction? What it is called? Abirami Sivaraja. Okay, Abby? Sorry? Sorry?
She typed in the chat box.
Oh, okay. Okay, so the chat. Uh, okay, friction force and tension. Okay. So this is friction and then this is the tension. Okay, the tension must be along the string. And then the friction is always oppose any force that make the object move. Okay, so are there only two forces acting on the trolley? Ada dua sahaja ke? Or are there?
There's another two.
Okay, there are another two. Okay, to which direction is it? The other two forces.
One is to upwards and the other one is
Okay,
downwards.
one is upward, the other one is downward. So the downward force is the weight of the trolley.
Wait. and the other one is the normal
Yes.
force, normal
The one
reaction.
is the normal reaction because the trolley is placed on a table. Okay. So if you look at the free body diagram, actually there are 1, 2, 3, 4, 5, 6 forces. However, if we combine the force, look here, yang ini tension. Okay, this one is tension. This one is also tension. And the tension is in the opposite direction. So if we combine the system, these two tension cancel off each other. Okay, but if we are to calculate the tension, we have to focus at one system at a time. Boleh? Katalah kita nak kira tension kan. So you don't look at the other system. Trolley tu you jangan tengok. Focus only on the load. Kalau nak ambil load lah. If you want to focus on the trolley, then focus on the trolley only. If it is the tension. Because both system, the load and the trolley both have the tension. Okay. However, if you let's say need to calculate the friction, so you need to combine the system. Okay, so katalah I draw again this one. Okay, so this is tadi trolley on a table, and then we have a pulley, and okay, like this kan. And then for the trolley tadi ada friction, and we have also tension, we also have weight, and we also have normal reaction. Whereas for the load, we have weight and we have tension. Okay. So if we are to combine, this part kita boleh luruskan. So we can draw like this. Tension, tension. And then weight. And then friction. Weight and R. Okay. So let's say if we are to calculate the friction, this one we can cancel off and it will become like this. Friction, weight, weight and normal. Okay. So that is how we do the calculation if there are two systems involved. If you look at the diagram, there are actually two. One is the load, the other one is the trolley. Okay, so let's focus back on the diagram tadi. Compare the weight of the trolley W with the normal reaction. Okay, question B. What is the comparison between trolley and the normal reaction? Okay, so can Junyi, what can you say about the normal reaction and the weight of the trolley?
Yes,
Yes?
yes, teacher.
Yeah?
Yes, teacher.
B, please answer B.
What was the question again?
Compare the weight of the trolley with the normal reaction. Okay, this is the diagram. This is the weight of the trolley, and then this is the normal reaction. So what is the relationship? Or what is the comparison? One force bigger than the other, or are they the same? If you want to refer to the textbook, it is on page 12. Okay, page 12. Yes,
The
Judy.
weight is equal to the normal reaction.
Okay, so the weight is equal to the normal reaction. Because, why did you say that the weight is equal to normal reaction? IV. Why did we say that the weight of the trolley is equal to the normal reaction? Ivy, can you please tell us why is the normal reaction equal to the weight? Yes?
Is it because in stationary state?
Yes, okay. Because the trolley is stationary on the table at this point. Okay, vertically. They're stationary vertically. Okay, it's not moving vertically. So that is why we say that the normal reaction is equal to the weight. So C, calculate the resultant force acting on the trolley. Resultant force, kena tengok balik pada soalan. The trolley move with acceleration 4 meter per second against friction of 6 Newton. So if we look at or if we draw again the trolley, okay, the trolley is moving with acceleration and there are a friction of 6 Newton. 6 Newton. And then the trolley moves with acceleration 4 meter per second. Okay. And okay, so that's it. And we have friction. Yes. So the question asks us to calculate the resultant force. Okay, even though the trolley is tied to a weight, so we only focus here. Okay, so the resultant force acting on the trolley is the mass of the trolley, 1.5 kg, sorry, 1.2 kg. So which direction is the resultant force? Okay, after we draw the trolley with all the information given from the question, so now we need to identify which direction is the which direction is the resultant force. Can somebody answer me? Is it moving to the right, or is it the resultant force is to the right or to the left?
It's moving to the right because the thing is pulling the trolley down to the
Okay,
right.
so the resultant force is to the right because the acceleration of the trolley is to the right. Okay, however, we have okay, however, don't forget that the trolley have another force, which is T. Okay, and T is the tension of the string, and it is connected to the weight. So apa yang boleh kita buat? Kita boleh cancel off the tension of the string and kita boleh gantikan with the weight. Okay. So diberi tak? Okay. Sorry. So actually there are 3 forces horizontally, and once again the object is moving with acceleration and it has mass. So according to Newton's second law, resultant force, after we combine all the forces and the object is moving, resultant force will cause object with mass to accelerate. So as for the resultant force, we just multiply the mass to 1.2 with the acceleration, 4.8 Newton. So this is the value of the resultant force. Okay, so saya rasa ni saya buang dulu lah because they focus on resultant force sahaja. Okay, seterusnya, calculate the tension of the string pulling the trolley. Barulah kita draw again, 6 Newton, and then we already calculate the resultant force, 4.8, and the other force exerted onto the trolley is T. Okay, so since the question is only focusing on the trolley, so we only focus what are the forces on the trolley. Yang load tu kita biarkan dulu. Okay, so since there are three forces opposite direction and resultant force is the same direction as the tension, then we can say that the tension is bigger than the friction. So kita tolakkan and then we get the resultant force 4.8 Newton. So T is 4.8 plus 6, 10.8 Newton. So this is the tension of the string. Okay, so let's look again at the system. Tadi saya kata when there are two system linked together. When we want to calculate, we want to solve problem regarding the two system, we divide or we focus one by one. Okay, so kalau dia minta berkaitan dengan trolley, fokus trolley sahaja. Kalau dia minta berkaitan dengan load, you fokus load sahaja. Okay, so and then kat sini suruh compare weight dengan normal reaction. So we have weight normal reaction vertically and the object does not move vertically. Therefore, we say weight is equal to normal reaction. And then C, calculate resultant force acting on the trolley. The trolley is moving to the right at 4 meter per second with a mass of 1 kg. So this is due to resultant force. The acceleration is due to resultant force. So we can calculate resultant force using the mass and also the acceleration, and we can get the resultant force. Okay, and then as for the tension of the string, the past accurate resultant force, we know that the trolley have friction and also there is a string tied to the trolley. So we have another force which is the string tension. So since the resultant force is to the right, therefore we can say that the force that is to the right is bigger, which is the tension. So tension minus friction, you get resultant force. So T minus 6 Newton equals to 4.8 Newton. Therefore, the tension of the string is 10.8 Newton. Okay, so this is the explanation for example 3 at page 12 D. Okay, so E, what is the mass of the load? So now, if we focus back on the load, it is connected to a string. So the force is tension and also the weight. Okay. And from the trolley, we already calculated the tension. Therefore, we know the value of tension. Okay, kenapa kita boleh ambil 10.8 tu sebagai tension? Because the trolley and the load are connected with the same string. So they have the same tension. Only the tension at opposite direction. For the trolley, the tension act to the left, to the right. But for the load, the tension act to the upward. Sorry, the tension act upward. Kalau kita tegakkan, dia akan act opposite direction. Okay. So since we have the tension of the string, and because the trolley is moving at 4 meter per second and it is connected to the load, so tak logik lah kalau trolley saja yang bergerak. The load will also move because it is connected. Okay, so here the load will move downward at acceleration 4 meter per second per second. How do I know that? Because it is connected to the trolley. Okay, and since the trolley is moving to the right at 4 meter per second, so the load must also fall downward at 4 meter per second. Okay, so sekejap. Okay, so since we don't know the mass, ni ada dua anu yang tak tahu ni. Tidak ada. Okay, so since we have yes. So kalau awak tengok dekat page 12 pun dia ada dua persamaan. So let's look at the system. Okay, so the resultant force is equal to ma. Because the object is moving downward, so the resultant force is downward, where we multiply mass with the acceleration. Okay, so resultant force equals to 4m. Okay, and if we look at the system, W minus T equals to F. Okay, kalau nak kira resultant force, the bigger force minus smaller force, you get resultant force lah. So W is the weight, mg, minus T 10.8, and resultant force is 4m. Okay, and then G is given as 9.81. So we can substitute G with 9.81 times M minus 10.8 equals to 4M. Okay, so kita boleh solve lah the calculation. Okay, so this is how they get the answer for example 3 from page 12. So far, for example 1, 2, and 3, are there any question? Can you follow? Nah, ini apa jalan kerja yang ditunjuk dalam buku teks lah. Okay, so boleh follow Okay. So yang ni pun soalan lebih kurang yang macam saya dah tanya. Okay, so resultant force kita dah cover dan kita pun dah bincangkan beberapa soalan sebelum ni yang saya bagi pada previous class. Okay, cuma I just want to show you how they get the answer for the example tu sahaja. Okay, for now we are going to continue with the next one, which is resolution of force. Okay, so resolution of force. So for resolution of force, it involves force that is exerted with an angle to an object. Okay, for example here, we have the boy Okay, we have the boy being pulled by someone at this angle. Okay, so previously I've told you we can only combine forces that are parallel. So force yang tak parallel tak boleh combine directly. So now we can combine, or we can calculate resultant force for normal reaction and weight of the boy straight away. Opposite direction, one positive, one negative, tambahkan. Okay, but for friction and pulling force, we cannot simply add the forces together because they are not parallel. Okay, so the pulling force can be resolved into two components. So let's say we have a force. Okay, the object is being pulled with force 2 Newton, and the force is making an angle at 30 degree. Okay, so firstly, this force can be resolved into two components, and the two component is perpendicular to each other. Okay, if you look at, if you refer to textbook or to reference book, the resolution of force is horizontally and vertically. Okay, and then the second one is you need to determine the direction of the component forces. If the force is going outward, dia keluar from the point here, dia macam keluar kan. So the component will do the same, dia akan keluar outward juga. Okay, if the force is like this, going inward into, katalah macam ni, kosong-kosong daripada graf, contoh. So the component will follow. Okay, horizontal component, vertical component, the direction will follow. Okay, so that is what you need to remember. Okay, so pertama tadi, if you have a force that is exerted onto an object at an angle, so let's say this is 30 degree also. Okay, you can resolve the force into two components, one horizontally, one vertically. But I don't like to use horizontal vertical because depends on the situation. Sometimes the force is not horizontal and vertical. The force is being resolved not horizontally, vertically. Okay, tapi what I can say that is when it is being resolved, satu parallel to the surface, the other one is perpendicular. Okay, so kalau dalam kes ni surface-nya adalah horizontal, so one is horizontally, the other one is vertically. Same goes with the second one, B, here. Also horizontally and vertically. Satu. The second one is the direction of the component forces. Because this is a vector, direction plays an important role. Okay, itu dua. Kemudian is the value of the component. So let's say the horizontal one, we call it as fx, and vertical one, we call it as fy. Okay, so in order to calculate fx, we use Pythagoras theorem. Okay, so yang ini biasa saya beri pada my ex-student dulu yang kita belajar bahasa Melayu, kita tak belajar bahasa Inggeris. So pada saya cakap, kalau komponen tu sebelah angle, so dia dekat dengan angle, kita panggil dia kawan. So fx, angle dia sebelah, dekat, kawan, so cos 30. Sekejap. Okay, so fx is the force 2 Newton times dekat sebelah ni kawan cos 30. Okay, how do we get cos 30? Menggunakan Pythagoras theorem. Dan saya bagi tahu dekat student saya cara senang nak ingat sebab saya ajar dalam bahasa Melayu dulu. Dekat kawan, jauh. FY ni jauh kan? Jauh setan. So 2 sin 30. Okay, tu yang saya ajar student saya lah. Tapi dalam bahasa Inggeris tak boleh guna dekat kawan jauh setan sebab dia dah jadi huruf lain. Okay, if you want to follow my method, then you follow lah. Kalau you tak nak, you have another method to remember, then you use that. Okay, but we get this is from Pythagoras theorem. Okay, so for B, for this system is also the same. Fx is, let's say this one is 3 Newton. So 3 cos 30. This one is 3 sin 30. Okay, so this is how resolution of force is being done. Force yang buat angle, we resolve into two perpendicular component. One we can say horizontal, the other one we can say as vertical. Okay, and then direction of the resolution force plays an important role. Dia follow dia punya main force, direction dia. Okay, kalau main force dia macam keluar macam tu, yang lain-lain pun akan keluar juga. If the main force masuk dalam point kosong-kosong tu, yang lain pun akan ikut point kosong-kosong. Remember, this is a vector, direction plays an important role. Okay, kalau awak salah direction, jawapan akan silap. Okay. So, step in determining the resolution of force. So, ini adalah dalam buku teks. So, dia kata draw horizontal components seperti yang saya bagi tahu tadi, and then horizontal. Okay. Horizontal component kita bagi nama Fx, vertical component kita bagi Fy. Okay, and then this is the method of determining the Fy and Fx, okay, using trigonometry or using Pythagoras theorem. Okay, so let's look here. Aim to resolve a force onto two components for an object moving in a direction not parallel to the direction of the force. So this one is activity. So this is our homework for today. Kejap je dah dekat pukul 1. Okay, so you look at page 15. Okay, this is on page 15 on the textbook. Okay, page 15, activity 1.5. Okay, so the aim is to resolve force into two components for an object moving in direction not parallel to the direction of force. So, you need to determine the magnitude of horizontal component and vertical component for the pushing force. And then for diagram 1.18 pun kena kira component of the boy and component perpendicular to the inclined plane. Okay, and as for discussion, what is the purpose of resolving force into two perpendicular components? And number 2, discuss the suitability of resolving force into components that are not perpendicular. Okay, so that is our homework. Page 15, activity 1.5. Okay, so what you need to do after you answer, where to answer this? You can answer this in your exercise book. Okay, and please share your answer. Either you snap the picture and give it to me to mark. Okay, or I can assign this in the class Google Classroom, but 5E I belum buat lagi class for you. Okay, so for 5E nanti I akan buatkan kelas Google Class for 5E. You can send in your assignment in the Google Classroom, or kalau susah sangat nak masuk Google Classroom, just take the picture untuk you punya jawapan and then share it personally with me. Tapi kena bagi tahu nama lah. Because I don't know siapa yang jawab. Okay. So any question on that? Okay, so since there is no question, we stop here. So remember, homework. Can you please hand in the homework before our next class, which is Monday. Okay, the latest is on Monday. Monday berapa hari bulan? 1st of February. Okay, so with that, thank you class.
Thank you, teacher.
Okay.
Teacher,
Yes.
teacher, in our timetable, our